Okay, so this video is meant for my Concepts of Algebra 2 students. We have a test coming up on Chapter 2 on Friday. And this review video is covering the last 3 sections of the Chapter 5, 6, and 7. You have a previous video covering 1 through 4, which you should watch as well, and bring those notes in to Class 2 for your test on Friday. As promised, the first 2 things I have listed here are the slope and the point slope forms. You need to write these down and have them with you. If you don't have these formulas, this test is going to be hard. So make sure you copy down these 2 formulas. We're going to use these when we approximate the best fitting line. Okay, so here is problem 1. We are going to write the equation of a line that passes through the given point, which is 1, -1, and is parallel to the given line. So we need to know a couple things. Number 1, to write an equation, we have to use point slope form. Y minus y1 equals m times x minus x1. And in order to do this, we need a point and we need the slope. Okay, so what is our point? Our point is 1, -1. Good. Now, what is our slope? Well, we don't know, but it does say that our line is parallel to the line above. And we need to know that parallel means the slopes are equal. So what is the slope of this line up here? This slope is -3. It's the number next to the x. So what is our slope we're going to use? -3. And here is the important information we need. This point and this slope. And now we can use point slope form. Y minus, now y1 is this -1, equals our m, which is -3, times x minus, and this is my x1, 1. This becomes y plus 1. We distribute the -3, this is -3x, and then -3 times -1 is +3. We then subtract 1 to get it in slope-intercept form. The 1's cancel. -3x plus 2. And there is the equation of our line that passes to the point 1, -1 and has a slope of -3. Okay, here's our second problem. We're going to find the equation of a line that passes through the given point and is perpendicular to the given line. Okay, so again, sorry about the move down. Again, we need to use point slope form to find the equation of this line. Now, in order to do this, we have to identify a point, and we have it, 1, 1. And we need a slope, which we do not have. However, they told us that our line is perpendicular. So, to you, perpendicular should mean that the slope of one line is the opposite reciprocal of the slope of the other. Okay? Opposite reciprocal. So up here, the slope is -2. This is -2 over 1. So our slope is going to be the opposite reciprocal. Well, the opposite of negative is positive, and we flip. We flip the 1 and the 2, and it becomes +1/2. And here is the point, and here is the slope we're going to use in point slope form. So we do it. Y minus, now my y1 is 1, equals my slope of 1/2 times x minus, and my x1 is 1. This y minus 1 stays the same, and this is 1/2 distributed. So that's 1/2 times x is 1/2 x. 1/2 times -1 is -1/2. If you use decimals, I don't care, but they better be exact in these kind of problems. So we add 1 to both sides. And over here we get y, the 1's cancel, equals 1/2 x. And now this problem is difficult. -1/2 plus 1. So down here I'm going to do it side to side. -1/2 plus 1. Well, think of 1. I'm going to use a different color. Think of 1 as 1 over 1. And I need a common denominator between the 2 and the 1. So multiply this 1 by a 2. If I do it to the bottom, got to do it to the top. So this problem is really -1/2 plus 2/2, or 2 over 2. And what does this come out to be? Well, the bottom stays the same, and we do -1 plus 2. 1 negative, 2 positives, leaves you with 1 positive. +1/2. And this is the number that goes right here, +1/2. And that is the equation of the line that is perpendicular to the given line through the point 1, 1. Okay, problem 3 is a word problem. So it says, in 1979, 13 grizzly bears with first-year cubs were observed in Greater Yellowstone ecosystem. So I'm going to write that down. 1979, 13. So in 1979, 13 bears. In 2004, the number observed was 49. So there's 49 bears. And then it says use the verbal model. We don't have that, so I'm going to not include that. Use the verbal model to write a linear model for the observed number of females with first-year cubs in Greater Yellowstone ecosystem from 1979 to 2004. Okay. So what I need here is I need these two things to become points. Not like that. I need points. And I don't want to use these big years. So what I want to do is I want to kind of zero them out. And I want to take x, the x-coordinate, as years since 1979. So x is going to be years since 1979. So to find that, take your years and subtract 1979 from them. So 1979 minus 1979 is 0. There's the x for this first. And we should know that time is always x, so that's 0. The y is then going to be the number of bears, 13. To find the x that goes with 2004, we're going to take 2004 and subtract 1979. And this comes out to be 25. That's my x, 25. And my y is the number of bears. So now in this problem, and maybe in some other problems, you're given 2 points. To find the linear model, we have to use this formula. Y minus y1 equals m times x minus x1. We have to use that. That's called point-slope form. But it needs a point and the slope. It needs a point and it needs a slope. We have 2 points and no slope. That's not good. We need to first find the slope. So the first thing we do in this problem, and I'm going to scroll down, is we have to find the slope. So I'm going to come over here in a different color, and I'm going to find the slope using y's over run. So we'll take 49 minus 13, 49 minus 13 over 25 minus 0. This is 36 over 25, and I want a rounded number to 2 decimal places in this problem because it's a word problem. 36 divided by 25. It comes out to be even, 1.44. Good. There's my slope. Well, what point should I use? Well, here's the choice. You have choice. You can pick either 0.13 or 25.49. If you want to choose 25.49, be all my guest. But I'm going to choose 0.13 because 0 is involved, and I think that should be simpler to work with. So there's my point. There's my slope. Plug it in. Y minus 13 equals 1.44 is my slope times x minus 0. Now, this is interesting here because x minus 0, guess what? The x stays the same and the 0 goes away. This is just 1.44x. There's no distribution. And now I'm going to add 13. 13's cancel. The 13 does not combine with the 1.44, so you just write it after. 1.44x plus 13. And there's your equation for the number of bears x years after 1979, or x years since 1979. But again, 2 points, find the slope, then find the equation of the line. Okay, here's our 4th problem. This is going to be a word problem, so let's see. It says, weight varies directly with the force of gravity. Stop. Stop right there. Stop, stop, stop. Stop the presses. Weight varies directly. Boom. I already know what I'm working with. Y equals kx. Boom. I know. That's what I'm working with. Varies directly means that. Now, it says weight varies directly with the force of gravity. So maybe we should say, let's let y be the weight, and let's let x be the force of gravity. So maybe you want to write that down so you know what you're dealing with. The other thing you could do is you could change the letters to match something else. So you could let w be y and I don't know, f be x. But let's just leave it as y equals kx. Y is the weight, x is the force of gravity. Remember, go in order. Right? Let me draw an arrow. Go in order. Y equals kx, right? This is y. and there's your x. Okay, so go left to right. Let me scroll that down so you can see that a little bit better. Okay, go left to right. Y is your weight, k is your force of gravity. An object that weighs 6 pounds on Earth weighs only 1 pound on the moon. The rocks gathered from the moon on the mission weighed 46 pounds on Earth. How much to the nearest pound did the rocks weigh on the moon? Okay. Well, here's what I have to say. Okay. The weight on Earth and the weight on the moon are different. Actually, I'm sorry, I'm going to scratch this problem because it's more involved than we need to do. I apologize. We'll do a different for here in a second. Okay, I'm very sorry for that. I bit off more than I could do with that problem. So we're going to do this problem instead, the wave problem. Maybe you remember this from class. However, that last problem is good because you'll see that it said very directly. So here's this problem. A wave's length is the distance from its crest to the crest of the next wave. Okay. The height h at which a wave break varies directly with the length L. So here we go. I already know y equals kx. I already know that. Now, in this problem, they give me height h, length L. Remember, go left to right. So I'm going to replace h the height, is the same thing as y, and L, the length, is going to be x. So I'm going to replace y with h and k with, not k, sorry. I'm going to replace y with h and x with L. K is the constant, must remain the same. It says a wave that breaks at a height of 3 feet, so it's giving me some information. So at a height of 3 feet, its length is 21 feet. So it's giving me a pair of numbers, h and L, okay, or same thing as like y and x. First part, write an equation that relates h and L. So remember, when it says write the equation, first part is find k and put it in there. Well, in order to find k, we have to replace h and L with numbers. Well, we have them. H is 3, k is k because we're trying to find it, and L is 21. So we're going to divide by 21, divide by 21. Now, in your calculator, 3 over 21 does not simplify nicely, so I need to do it by hand by dividing each by 3. And we get 1 over 7, and that's k. Do not round that number. That is k, but that's not the final answer for part 1. The final answer for part 1 is the equation that relates h and L. This equation with k replaced. H equals 1/7 L. Your final answer is the equation, and that's part 1. Part 2, now it says predict the height of a wave if the length is 35 feet. So now it's giving me another L value. L is 35. Well, I have this equation right here that has an H and an L. I can replace L with that number 35, and I should be able to find H. And here I go. 1/7 times 35 is 5, and that's 5 feet. And the height of this wave is 5 feet. Good. Okay, so here's this problem. This problem is about identifying direct variation. The question is, tell whether the data shows direct variation. If so, write an equation that relates x and y. So this is a direct variation equation, a problem, so we still are thinking about y equals kx. However, to see if the data shows direct variation, we must see if k stays constant. That's the question. Does k stay constant? So what we're looking for are k values. Well, here, this equation, we can solve it for k by dividing both sides by x. And we get y over x equals k. This equation is what we need to use for all of our data to see if k remains the same. So let's see what happens. Okay? So I'm going to use a different color for my data. Let's see. Okay, so the first one. These are my x's. These are my y's. So I plug in y. 4 over 5.4 equals k. And doing this in the calculator, the k equals 4 divided by 5.4. 0.7407 ... Okay, so I'm going to leave that alone. In this problem, since they're word problems, file size and all the time, leave it as a decimal. Okay. Now let's see if the next set of data works the same way. We're going to do y over x, this equals k. So this is the first set. This is the second set. 9 divided by 12.2 is 0.7377. Okay, right now, are they the same value? Are these two the same value? No, they are not the same value. So what are we going to say? We're going to say this does not show direct variation. Not direct variation because k is not constant. Or k changes. Okay? Even if it's by this little bit, we are going to say that this is not direct variation. Alright, very good. Okay, and now here's the biggie. This is the 1/6 of your test problem. Approximate the best fitting line, right here. Okay? So we're going to break it down step by step for us. We're going to do the whole shebang bang and figure this problem out. And we need to feel confident going into this test that we can do this kind of problem. Okay, so here's the data. Who cares? X is there, Y is there. We're going to draw a scatter plot. Remember, it's a 4-step process. First, plot the points. Okay? Let me get a graph up for myself. Okay, and here's the graph I'm going to get, and notice that it's only the positive first quadrant, right? X is positive, Y is positive, because look at my numbers, they're all positive. Now, X's are counting 0, 1, 2, 3, 4, 5, so I can count by ones, okay, that's fine. So I'm going to count by ones on my graph. So I'm going to label that, so this would be 0, 1, 2, 3, 4, 5, 6, 7, and on, but I don't need to. Now, the Y is interesting, because look at the Y. It's between 1280 and 1370. So maybe the range should be something like 1250 to 1400, right? That would encompass all of these numbers, 1250 to 1400. So maybe I'll count by, let's say, 20s. Okay, I think 50 might be too big, so let's count by 20s. And again, this is like a crapshoot. You have to kind of figure out what you want to do. So I'm going to put a page, a break there, okay? And I'm going to make this one. I'm actually going to start at 12. I'm going to try at 1260. Or actually, I'll start at 1280. Let's start at 1280, right? We don't need anything lower than that. So 1280 would make sure that that point's on there. Bear with me as I write small. And then this is 1300, and that's 1320, 1340. 1360, 1380, 1400. Okay? It's hard to see, I'm sorry. 1400, 1420. So this is 1280, 1300, 1320, 1340, 1360, 1380, 1400, 1420. So we're counting by 20s. And this is by ones. And again, I put the little break there because y start at 0, right? Start at the smallest y value. And now I'm going to plot my points. Okay? So 0, 1288. Like right there. 1, 1309. 1, 1309. Almost 1310, which would be right here. Okay? We could have almost done this by tens as well, but, you know, it's okay. 2, 1330. 2, 1333. So that's 1330 is in the center, so we'll go just right around the center. 1333. 3, 1349. 3 and 1349 is like right there, almost 13. I'm sorry, almost 1350. So it's in the center. Right there, almost 1350. 4, 1366. 4, 1366. This is 1360. So just a little bit more. And 5, 1370. And there you go. And there's my data. Okay? So that's the first part. Plot the points. Next, it wants you to describe the correlation. So the question is, how are these going? Okay? So this is part B. Describe the correlation. Well, they're going up. Your choices are positive correlation, negative correlation, or no correlation. I think that these have a positive correlation because the points are going up. They're rising. Okay? Now, draw the line of best fit. Now this is going to be hard for me to do because I don't have a straight edge, so bear with me as I draw it. Okay, so here's my line of best fit. I got 1, 2 points below, I got 1, 2, 3 points above, and 1 point on it. Okay, so I feel like this is a pretty good line of best fit. So if I look at my graph, so I drew my line of best fit. That's the second step. Draw the line. Again, not all the points have to touch the line, and that's the point. Third step in approximating the best fitting line, find your 2 points. Well, this point definitely touches, so I'm going to use that point, which is 1309. And then I'm going to pick, let's see, of the points, I'm going to pick this point right here. Should be something that's either on the line or close to on the line. I don't want to pick the point right next to my other point, so I'm going to pick this one right here, and that is 41366. And again, your 2 points can be different than mine. It's okay. So my 2 points now are 1, 1309, and 4, 1366. So now I have the 2 points. I need to find the equation of the line. I'm going to slide this down because I don't really need the data anymore. So to do this, I need point, slope, form, which means I need a point and the slope. I only have 2 points. I must first find the slope. Find it over here. Slope equals y2 minus y1 over x2 minus x1. That is y2, 1366 minus y1, 1309 over x2, 4 minus 1 is 3. Minus 1. x1 is 1. So this is going to be, my calculator says 1366 minus 1309 is 57. 4 minus 1 is 3. Divide them. If it's not even, round to 2 decimal places. Mine came out to be even. 19. Good for me. I got a 19. That's my slope. So now I'm going to use point slope with my slope here, m, and the point of my choosing, which I'm going to pick the smaller one, 1309. So I'm going to bring my point slope form over here, and I'm going to do y minus y1 is the y of your point, equals m times x minus x1, the x of my point. Y minus 1309 equals 19x. I distribute the 19. 19 times negative 1 is negative 19. I add 1309 to both sides. I'm going to scroll down for a second. The 1309's cancel. Y equals 19x, and negative 19 plus 1309 is 1290 positive. Here is the approximate equation of my best fitting line. And that's step 4. Find the equation. And that's a good equation. Excellent. So that was all part B, or part C, I'm sorry. That was all part C. So if you want to label it, this was part C. Find the equation of the best fitting line. Approximate the best fitting line. 4 steps. Now, D. Part D, and I'm scrolling up and down, sorry to keep going. Use the best fitting line to predict the number of commercial television stations in the United States in 2011. Well, look at this number, 2011. I'm going to use red. There's no 2011s up in my chart. There's the year 2000 here, but look what it says. X is years since 2000. So notice this is 0, 1, 2, 3. That's 2000, 2001, 2002, 2003, 2004, 2005. So what they're doing is they're taking this number and taking away 2000 to see what the X value is. So when I come down here and do D, and I'll do D in green, to find out 2011, I first need to take away 2000. Years since 2000. And I get 11, and that's my X value. So you know what I do with this X value? I take this X value, and I plug it in to that X, and I figure out what Y comes out to be. Y equals 19 times 11 plus 1290. 19 times 11 is 209 plus 1290 is 1499. Right, that's all of it together, 1499. So what did I just find? The number of commercial television stations in the United States. 1499 television stations. And there you go. And that is the full problem. This is 1/6 of your test, this problem. If you can do this problem, everything else should be a piece of cake, because you have to find the equation of a line, which is one of the biggest things you have to do on this test. So again, hopefully this was helpful. You bring this in along with the other YouTube notes, and you have a great test on Friday. Thanks for watching. Sorry about the mistake on 4.